We're looking at question 36 in the AP Statistics Midterm Review, and we're asked to use scenario 3-2, which we're given a table with an explanatory response variable, and we're given a scatter plot. So we have that information. Let's just go ahead and read 36 to see what's going on. And in this one, we're asked to look at what happens if we transform or we change the scale of one of the variables. So we're told, hey, if the heart disease death rate, which is our response variable on the y-axis, if we change that from 100,000 people to deaths per 1,000 people, how would that affect our correlation, our R value? So really we're analyzing how does transformations or scaling affect our correlation between our explanatory and our response variables. Now if I look at choices A, B, C, D, and E, what I'm going to see right now is that choices A, B, and D, and E, those four options deal with answering the question, how does changing the scale or units affect the value of R? Now, choice C says there is no change. So A, B, D, and E says there is a change. That if I change the scale, if I change the units, that I'm going to also be somehow changing the value of R. C says there is no change. It doesn't matter what your units are. And now that's really interesting. That's really what we're trying to address is, does R affect, is it affected by transformations? And the answer to that is, no, it's not. R is not affected by transformations. It is really interesting that it is not. That's one of the actual characteristics of R. Now, what R does, it describes the relationship that's going on, the linear relationship. How strong is it? How weak is it? And in this case, we have it negative. But really what happens, let's say I want to go from 100,000 to 1,000. What I could really do is I can just go ahead and change this to per 1,000. That took care of that on the y-axis. Now, really what that means is I'm dividing by 100, correct? So really, I can also do this. I can go ahead and change the scaling here. I'm going to need that 5 there. I'm going to need that 5 there. I don't need those zeros. Don't need those zeros. Don't need those zeros. And I put a decimal point, I just changed the scaling on the y-axis. None of those points at all would shift vertically. I mean, that's it. That's the graph. And so that's really what's going on. Now, another reason why, and this is really important, this will actually help you with one of the other problems on the midterm review packet, is the definition of R. If we look at it, the formula, which we don't really use, but you have to understand, is 1 over n minus 1 times the sum of what we observe minus what we expected for the x value, the explanatory, divided by the standard deviation, same thing for the y, the response, multiplied together, and we add all those for every single observation. That's annoying. But if I look at this, that's actually really important. And the reason why is this formula right here and this formula right here, those are your z-score formulas. I mean, this is really the z-score of all your x, and this is really the z-score of all your y's. We do know that z-scores are not affected by transformations as well. So that is one thing to keep in mind is for 36, it's a nice idea of what R is. R is not affected by transformations, and R does not have units. That's something to keep in mind for the characteristics of R. So hopefully that helped you with 36.